In this section, we are looking at the graphs of some common functions that you should know and be able to recognize by sight. So in example 6, A and B, we are given two equations of lines. I can tell those are lines, one, because there's no powers, right? There's no x squared, x cubed, any higher power other than x. There's also no additional variables except for x and y. There's no square roots, there's no absolute values. This is clearly a linear function, and I could, to graph or sketch a rough sketch of a graph, I could solve this for y. For sure, subtract 3x over, divide by -6, and I can find the slope and the y-intercept and do a sketch from that. But honestly, if I was given this graph, I probably wouldn't bother finding the slope and the y-intercept because it's really set up nicely to use the x and y-intercepts. Which is what you get. You get the x-intercept if I plug in 0 for y would make this term 0, and 3x equaling 12 means x is going to be 4. So I know this graph crosses at 4, 0, and then I know my y-intercept is what I get when I plug 0 in for x. If I plug 0 in for x, that means that's going to be 0, and -6y equals 12 gives me -2 for my y-intercept, which I did have that a second ago, and I can just connect the dots and get my graph. Again, I would have had the same function. If you remember, it was y equals 1/2 x minus 2, which crossed at -2, and if I go up 1 over 2, up 1 over 2, I end up in the same position. The second example B is also a linear equation, that is a line, where I can see clearly that the x-intercept is 3, and in fact, all of the values on my equation for x will be 3. This is a line, vertical line, where x equals 3. If it was y equals something and that was all I had, then it would be a horizontal line. So that's two examples of linear functions and how to quickly sketch a graph. In C, we start talking about polynomial functions. And you'll notice on each of these, I have just 4 examples. We could continue, like there's nothing to stop us from going y equals x to the 6th, y equals x to the 7th, and so on. But hopefully you have some instinct here that with polynomial functions, the power gives you the basic shape of the graph. So for this first one, where y equals x squared, you could plot some points if you want to, but you're going to get your basic quadratic parabola equation there, and then that's my y equals x squared and y equals x cubed. Hopefully remember the sort of shape of that graph. Sort of snakes just through the first and third quadrants. And y equals x to the 4th. Again, if you're unsure, you can always plot a few points, but it kind of looks like a parabola, just like y equals x squared. And in fact, all even functions will kind of have this same shape, and odd functions, there's quite the delay. As I'm graphing this, will have the same basic shape. They're just going to rise and fall faster. The higher the power, the steeper the graph gets. So again, even functions have that parabolic shape, and odd functions are their ends go opposite directions, right? One goes up, one goes down. It doesn't really have a name. I'd always just call it this kind of snakes through the graph. Now, exactly what that looks like when you start adding more terms, right? So I have, this is a polynomial, sort of a generic polynomial where my a's are different coefficients. X to the power of n minus 1, minus 2, minus 3 could be all the different parts of a graph. So if I'm given a function, I might not know everything about the function, but the leading coefficient tells me a significant amount of information. So as we said a moment ago, if it's even, both ends will go up, and if it's odd, the ends go in opposite directions. However, that wasn't really totally accurate because they were all positive, right? The leading coefficient, they were all just x to the power of something. So when you're looking at a function, and that you can see let me get the right thing here, that it's a polynomial, right? Maybe it's x equals 2 x to the power of, let's keep it even, x to the power of 6 plus, and who knows how many pieces there are inside of this, right? I don't really actually care about all of this. I can graph it in more detail with all of that, but the leading coefficient test means you're just looking at this first term and looking at, first of all, I see that it is even, the highest power is even, which means both ends are going to go up. The fact that this coefficient here is positive tells you both ends are going to go up, up to the left, up to the right. Let me back up. I want to rewind. I said because the power was even, both ends go up. Because the power is even, both ends go in the same direction is what I meant. They could both go up, they could both go down, and what determines that is the sign, if that coefficient is greater or is positive or negative. So in the case that your leading coefficient is positive, and the degree is even, then both ends will go up. And if that leading coefficient, if I had something like this, even power still, and whatever, I don't even care about the rest of it, but that leading coefficient is negative, that is what tells you that both ends are going to go down. Now, what happens in the middle here, it can, be kind of loopy like this first one is, where you have lots of like ups and downs going on in the middle, but it does tell you what's happening with the ends. Now, specifically, we'll get into that later, I guess. So if it's odd then, and the leading coefficient is positive, that's what that says, that first term, the highest degree term, has a positive coefficient, then it means it's going to go up to the right and down to the left. The odd power tells you the legs, or the right and left side ends, go opposite directions. The leading coefficient being positive tells you it's going to end going up, right? So the graph as a whole increases. Okay, yes, there's a little part in here where that decreases, but as a whole, it's an increasing graph. As I go from left to right, I start at negative infinity and I'm going to end at positive infinity. And when that leading coefficient is negative, then it's going to fall to the right and go up to the left. So you'll see overall, whatever happens in the middle, however many squiggles you get, overall the graph is going down. So it's going to end in the negative direction and start in the positive direction. So, long story short, notice these graphs are dashed in the middle. That's because we don't have really the information on what's happening in the middle. All I know is that if that first degreed term is even, both ends go in the same direction, the sign determines whether they both go up or down. So even and positive means both ends go up, even and negative means both ends go down, and whatever's happening in between would require more investigation. If it is odd, then the ends go opposite directions. Being positive means it's going to end on a high note, and it must have started pointing down, and vice versa. If it's negative, it's going to end going down and start going up. And again, whatever happens in the middle, we can't determine from that leading coefficient test just what the end behavior is. But end behavior is an important part of the graph. So hopefully that's familiar to you. We'll come back in a second and talk about some other functions.